Hi everyone, in this video we will see about different types of protective relays. So protective relays are broadly classified into the following three categories based on their technology and based on construction, based on operation. So what are those three types? First one is electromechanical relays, and second one is static relays, and the third one is numerical relays. So these three types of relays are main important. So these three types are classified based on their what type, based on technology, and based on construction, and based on operation. So we have other types of relays also. So these relays are depends on the operating principle and applications, right? So we'll see the first one is electromechanical relays. So first one, electromechanical relays. Most electromechanical relays use either electromagnetic attraction or electromagnetic induction principle. So these are the two principles electromechanical relays will operate, either maybe electromagnetic attraction or electromagnetic induction principle. So such relays are called as electromagnetic relays. Electromechanical relays also we can call it as a electromagnetic relays. See, these electromechanical relays again they classified into different types. The following are the principal types of electromechanical relays. The first one is electromagnetic relays. So electromagnetic relays again classified into two different types: attracted armature relays and induction relays. Attracted armature and induction relays. So again electromechanical relays are also called thermal relays. So again these thermal relays are attract uh, attracted armature relays. So we'll see the first one, attracted armature relays. So attracted armature relays again these are classified into different types. So these relays are classified based on their construction of attracted armature relays. So first one, so hinged armature type, and second one is plunger type, balanced beam type, next one moving coil type, next one is polarized moving iron type, reed type. See, first one hinged armature type we will see. So these are the two different types. One is hinged armature type, and another diagram is diagram B shows the modified hinged armature type. See here every hinged armature type relay will have one coil. So coil we can see in this diagram. So this is the coil. So this coil is energized by an operating quantity proportional to the system current or voltage. System current or voltage. So V voltage or current. So once this coil is energized, so what will happen? So this coil will turn to produce the electromagnetic flux. Electromagnetic flux. The flux will convert into force. Electromagnetic flux will produce. The flux will convert into force. So due to the electromagnetic force, so what will happen? This coil will attach it to the armature. Attach it to this armature. So once coil is attached to this armature, this part will be attracted, or this coil will close to each other. So then signal will be generated in this tripping circuit. Signal will be generated in the tripping circuit. This tripping circuit sends signal to the circuit breaker. So what is the other one? Circuit breaker. The circuit breaker will trips the supply. Trips this supply. Similarly here also. So here this coil is energized by current or voltage, supply voltage. So once coil is exceeds the current, so here magnetic flux produced in this coil will be high. So once if it is high, so this armature part will close it to this armature part, and coil will be short circuited, or these two parts will join together, then signal will passes to this tripping circuit. So here tripping circuit will generate the signal will go to the circuit breaker, then the circuit breaker breaks the supply. So this is about hinged armature type relay. So next one, plunger type relay. So this is also one of the attracted armature type relay. So this relay will have following parts. This relay will have, what are the parts? One is solenoid, another one is plunger, contact, spring. So similarly here also, similarly in this type of relay also, attracted principle will happen. So how it will be see? So in this type of relay, so there is a solenoid and an iron plunger. So solenoid is here and iron plunger is here. So which moves in and around of the solenoid. So plunger will move the in and around of the solenoid. So this is the plunger. So this is the solenoid. So here this part is the solenoid. So plunger will move in and around the solenoid to make and break the contacts. The movement of plunger is controlled by a spring. The movement of plunger. So here we have a spring. The spring will control the movement of plunger. So this type of construction has however becomes absolute and it's draw more current. So this type of construction will draws the more current. Whenever current draws more, so what will happen? So this plunger will attach it to the contact. So this will be closed. So this relay will send signal to the circuit breaker. This relay will send circuit breaker. What it will do? So it will breaks the supply. So supply will break the supply and protect the healthy parts. So this is about plunger type relay. So one more type we will see the relay. So this is balanced beam type relay. So this relay will have pivot. So how many parts? First you see the parts: pivot, armature, control spring, and contact. So this is one operating current. This is a restricting current. So this is operating current IO. This is a restricting current. So what will happen? As shown in the figure. So here the pivot will move. So whenever current exceeds the preset value, what will happen? So this contact will touches each other, then signal will passes through the circuit breaker. So here we will check. So this type of balanced beam type relay consisting of a beam carrying two electromagnetic ends. So here what are the two electromagnetic? This is the one. These two contacts. One gives operating torque while the other restricting torque. The beam is supported at the middle. That pivot and remains horizontal under normal conditions. When operating torque exceeds the restricting torque, then armature fitted at the end of the beam is pulled, the end of the beam. So this beam is pulled and the contacts are closed. These two contacts will be close each other. So though then so this is once if these two contacts will close, what is the next step? So then this relay, this balanced beam relay will send a signal to the circuit breaker. Circuit breaker will disconnect the supply. So the beam type relays, balanced beam type relays are very strong, very fast operation. So usually require only one cycle, but is no accurate as it is affected by DC transient. So there is no affected by DC transient. So these relays are very strong and very fast operation. So this type of relays we can use in the high voltage supplies, right? Okay. So this is about balanced beam type relays. So one more type relay, moving coil type relay. So we'll see in next video. Okay. Thank you everyone.